Hi, welcome back to the next episode of the Keto Naturopath podcast on YouTube. So today I'm going to continue with choline because, when you go back to the basic research, when you go back to the studies that really changed the perspective of all subsequent studies after that. In other words, everybody started looking at something different. And I told you about how Dr. Yertel's agouti mice, when he gave them the methylating factors, the yellow obese, cancer-prone mice suddenly became healthy for subsequent generations. And so everybody redid that. And it was an easy experiment to do, but not to think about. He had to think about this thing. It's pretty easy to do. It wasn't real expensive. And yet, wow, look what happened. And then he redid it 8 years later, throwing in a toxin and then a group with methyl donors. And then he, basically made them not suffer the consequences of the toxin, of BPH, bisphenol A, that comes from plastics. And then he did a subsequent one after that of even soy. So all that was interesting. So that was a paradigm shift. Not so much in how he did this, but that suddenly it consolidated all that we knew in terms of, epigenetics, methyl donors, and so on and so forth. So I have to break for a second because this whole idea of epigenetics started back in the 40s with what they call the Dutch hunger famine, which is the end of World War II. And I did podcasts on this. I've also done videos on this in which they were boxed in and they starved for 6 months in Greater Amsterdam. And a lot of people died. A lot of people got sick. And a lot of those that were born there had consequences for the rest of their life. And it was interesting. They compared that particular set of people's response to starvation as opposed to the siege of Stalingrad, which was the other side of World War II in Russia, obviously. And what happened to them and their outcome is they basically had different long-term outcomes in subsequent generations. So that's where epigenetics began, saying, hey, wait a minute, the subsequent generations weren't starving and look what happened to them. So something came in and mucked up the genes, right? Something came in and turned on some genes and turned off other genes. And there was actually in 1942, I can't think of that man's name, came up with the reference of epigenetics. So call it 2000, it was really 2003, when Dr. Randy Uric at Duke did this experiment, 2003, and then 8 years later. And then, so it's like, wow, people saw that it wasn't just isn't that interesting, these two starvation areas, and these people with different outcome. He brought it down front and center. It says it can happen in one generation. In one generation, it can happen. So people started to stand up and take it pretty seriously. So with that, pretty much concurrent, lockstep, I think a little bit later, over at the University of North Carolina, 10 feet away, right? 10 miles away, maybe. There was Dr. Stephen Seisel. And so he was, figuring out about choline because he started up at MIT as a PhD MD and working in a lab that was about choline, and decided, looked into various things about choline. Choline had not been declared a nutrient yet, even though there was a lot of research going back 150 years with a poundage, many studies, even back to the same people who worked on the isolation of insulin, Best, and I can't think of the other person, Banting and Best up at University of Toronto. And so it was a rich amount of information for him to dig into. And now he's getting into women in terms of prenatal needs and pre-cord blood on babies that were born. And all this has become pretty fascinating. But still, in the late 90s, it wasn't declared a nutrient. So then it became a nutrient. Then the next question was, well, how much of this stuff you're supposed to have and where do you get it and where is it? So it continued from there. So finally, in 2006 and 2007, when he did this study that I've talked about a little bit, he took men and postmenopausal women and premenopausal women, gave them the same amount of choline on a per body weight basis, and then he dropped them all down to be deficient in choline. and then he gradually brought them up over time, you find they didn't respond the same. They didn't respond the same. Postmenopausal women and men, for the most part, responded the same, with some exceptions. We'll get into that. And so they started at this level, well, how much do they need and what's going to do and so on. So they had a rough idea, had been established what they call adequate intake. Adequate intake simply means if you take this, you're not going to be deficient. It's not your ideal amount. It's not the too much, what they call the upper tolerable limit. What they've come up with now is that men need 550 milligrams per day, but even that is insufficient and even in those studies in 2006 and 7, it showed that it was insufficient for 20% of the men in the study, still at that upper level of 550 per body weight, didn't get enough. And so consequently, they were suffering dysfunction. It was mostly skeletal muscle dysfunction, which is interesting. They couldn't measure, in any of them, they couldn't measure any sort of mental or brain dysfunction. That would have been PET scan. That was a little more sophisticated, but that would have been interesting, right? My guess is those who suffered muscle dysfunction would concurrently suffer brain, because acetylcholine is the driver for muscle and it's the driver for brain. But what we know is that. And so women tended to, postmenopausal women, when they became deficient, they all got deficient, remember, that they tended to get fatty liver. Not muscle dysfunction, but fatty liver. So how fatty liver, they measured that by MRIs. So, okay, that's what women have. And there was one that had liver dysfunction, but there was only one in the whole group that had liver dysfunction. So they were doing blood work and MRIs and, really fine-tuning it. And anybody who was in dysfunction was immediately addressed and they brought them back up to normal. But one of the things that's not talked about that came up in that study of 2006 and 7 with Dr. Zeisel was that 100%, everybody who was in the study had elevated uric acid. Elevated uric acid. I've talked a lot about uric acid in previous videos, certainly, and some podcasts, but that was never mentioned. Nobody talks about choline deficiency as being a primary cause for uric acid elevation. So 100% of the people had elevated uric acid, and guess what? Even when the study was done, nobody came back to their pre-study levels, to their normal levels. It took a number of weeks, if not months, for some to come back to normal. Now you go, well, that's really interesting. That's kind of what they say, a fly in the face of this conclusion, that everybody wants a simple answer. That, elevated uric acid is X. And this is what you need to do. It's a little more complicated, but there are some big things that need to be addressed, and they are probably the causes. So we've talked about elevated uric acid as being purine consumption, perhaps being dehydrated to an extent, and we went through all of that. But now there's books out saying, no, uric acid elevation is due to fructose and glucose. You have a diet, you have insulin resistance. That's a component. It's clearly a category, but it's not the main component. Here you had 100%. It wasn't even premenopausal, postmenopausal, men, women, nothing. It was 100% everybody. When they depleted their choline, they got elevated uric acid. That is a big deal, especially when I'm encouraging everybody to get uric acid meters and to measure their uric acid, because it does help, and it is strongly correlated with obesity and diabetes and insulin resistance. Clearly, that's the case. But here we go. I just showed you what this is. Well, the tie-in, and a little bit of a tangent here, is that choline deficiency is associated with obesity and diabetes and so on and so forth. Type 2 diabetes, I should say. Yeah, that's always been the case. One of the questions, and why I keep plodding along on all these different things and looking kind of for the minutiae and the things that have the stones that haven't been turned over, the conclusions that haven't been revealed, and yet they were studied a long time ago being 2006 and 7, right? That it's important to know the big reasons and to be able to address the big reasons. But the biggest issues that we have culturally really come down to two major categories, and from there everything comes. And it's why the hellaciously high rate of obesity and type 2 diabetes, category 1, and the other is why, and they're going up and up and up. It's not like it's a straight line, it's the rate is going up. So the rate is going up over time. So we're not just a trajectory where we can put a ruler to and say, yeah, this is where it's going to be. The angle is changing. The angle is also changing for the rate of increase of chronic diseases, specifically dementia and Alzheimer's. Alzheimer's being a subset of dementia. Why are they almost lockstep with diabetes and obesity? In the United States, I'll speak for that, but it's really worldwide, and it kind of spreads out to the degree that they have a Western diet. It's like, all right, it's diet associated. No doubt it's diet associated. And no doubt we can say things it's due to the processed foods and the undernutrition of it. Absolutely, all those are true. But those aren't good enough answers for me. I just find that's just a non-conversation. I would walk away if somebody said that, and here and sound bright and intelligent. No, it's not that insightful for me. Sorry. Don't mean to offend you. But now we're finding out that, wait a minute, stop the presses, as they say. Back to elevated uric acid is because of choline deficiency. Choline deficiency. And we know that elevated uric acid, I've talked about videos and other podcasts, is associated with increasing rates of dementia, is associated with insulin resistance. I just said that, is associated with, it could be the commonality. I hate to say there's one thing. There's nothing in life is just one thing. So it's not just one thing, but this is a big issue that hasn't been discussed. Hasn't been discussed. So that uric acid is, yes, about insulin resistance, is, yes, about dementia. But could it be so simple that it, yes, is also about choline deficiency? Oh my gosh. Oh my gosh. So now we have to say, well, how did we get here to choline deficiency? And please don't go, yeah, it's the processed food and the undernutrition. Got that? Push that to the side. We're not going there. That's not what I want to talk about. But what happens is if you give choline, you reverse these things. So I'm not saying you can reverse type 2 diabetes and obesity by giving them choline only, or you can reverse, but it might well be. Nobody's done that yet. Nobody's done that. Nobody's done that obvious thing. They go, no, do keto. Do keto. This is the keto naturopath, right? So I'm a big believer in that. Oh, no. But when people drop the carbs, which is basically down to 20 or less grams of carbohydrate per day for the classic ketogenic diet, what does that give them to eat? Some go way too far in the fat side of things. But let's say you've figured out not that much fat. Well, that then leaves protein. So assuming you're a whole food eater, what are your sources of protein? It's either fish, poultry, or meat. Meat being game, beef, lamb, you name it, right? So now your sources of protein contain a lot of choline, especially if you eat the organ meats. Now back to the whole purine thing, right? Now it's like, whoa. So they talk about, oh no, I went carnivore, and it changed my life. Maybe you went carnivore and increased your choline percent, and that changed your life. Nobody wants to look at that. That's too simple. A third grader can understand that. Yeah, that's right. That's right. I mean, you didn't have to get so complicated with keto. I think you have to drop all the refined carbohydrates, all that garbage food. You shouldn't be eating it anyway. So if you're thinking, I dropped my refined carbohydrates, and I'm thinking you're dropping your garbage, then we're good, right? It's what I've always worked with people on without sort of saying, we're now going to drop gram by gram all your refined carbohydrates. I said, let's take the garbage out of your diet for just a couple months and see what happens. Shazam! I was not thinking in my 16 years of practice that it was choline that I was now shifting a person to have a choline-rich diet. But that's clearly what I did. The other factor is, and looking back over these since the mid-50s, the whole idea of you shouldn't have saturated fats. This is going to like go off into another tangent. So you shouldn't have saturated fats. That was Ansel Keys and the whole 7 countries studies. It was handpicked and so on and so forth. What it did was saying, no, you need to have polyunsaturated fats, and therefore the Criscos, and therefore the corn oils and the soy plant oils for cooking oils, vegetable oils. That's where they are. There's soy or corn. That's a polyunsaturated. So people are now putting all that in over 70 years, and they're not having what their parents used to have and their grandparents used to have, which was the tallow, or was the bacon grease, was the suet. There you go. And lard. That was what I was thinking about. No, they're not going to, that's bad. Don't use any of that. Right? So they dropped all the saturated fats, which means they're probably not eating the things the saturated fats came from, which was the animal meats. Okay, then. So that was a very low choline advice. So now here's the introduction that it deserves a little elaboration, probably in another podcast. And in going back, I've talked about MCT oil a lot. In fact, that for a couple of years we had a product, MCT oil, and that was from what, 2015 to 2018, I think. We still have bottles of it. So C8, it's called seed MCT oil. So it's caprylic acid triglyceride. That's saturated fat. So what's been discovered back in the 70s, this is research that nobody even looks at anymore. Back in the 70s is when they started thinking about how can they make the ketogenic diet for pediatric epilepsy more convenient, and so maybe if they added MCT oil, which they knew was highly ketogenic. So what does that mean? That means you put in MCT oil, medium chain triglycerides, that either comes from coconut or palm, mostly palm, that you have that within 15 minutes, your liver changes that into ketone bodies, beta-hydroxybutyrate, acetoacetate, and acetone. So that's interesting. Within 15 minutes, shazam, it's like instant ketosis. Absolutely, it's like instant ketosis. So that was in the 70s. They're saying, maybe we can make it a convenient diet. Let's have, put this on their meats and so on, so they don't have to worry about adding gobs of fat. So it all got forgotten. But what was also discovered in the 70s, and then into the 80s a little bit, before it really got forgotten and then rediscovered, was that for alcoholic liver disease, fatty liver from too much alcohol, and non-alcoholic fatty liver disease, fatty liver from non-alcoholic reasons, choline deficiency, but push that aside, that MCT oil, saturated fats, will actually improve and restore the liver. Improve and restore an alcoholic fatty liver from alcoholic liver disease, and improve and restore a liver from non-alcoholic fatty liver? Absolutely. Especially in combination with choline. So the person, more than likely, and this is basically useful information right now. So if somebody has had too much alcohol and you think that especially if your kids, they've been binge drinking or whoever else you're worried about, believe it or not, MCT oil is something you should have them have. They don't guzzle it. They'll have heartburn if they do. But having that help their liver immediately within 15 minutes can create ketones, and from there you have all these other benefits. But the idea is that MCT oil is the driver here. That totally changes there's 4 stages of cirrhosis, by the way, and eventually ends up with death, or liver transplant. So as it begins to get more and more disease, if you're not at the last stage of fibrotic advanced cirrhosis, whether it's alcoholic or non-alcoholic, you can bring it back. Isn't that amazing? Absolutely amazing. I had never thought of it in that context. And I happened to stumble across a number of studies that talk about MCT oil. So the idea of choline as a deficiency in MCT, specifically to treat the liver, and the number one liver disease that is really escalating, now that I've said there was Alzheimer's and dementia and chronic disease and diabetes, it's non-alcoholic fatty liver disease. So there you go. Here's the solution. Does it get any easier? It's not real complicated. And the confirmation, and let me go in the opposite direction. I talked about Ansel Keys, and I talked about he advocated don't have saturated fats, have the polyunsaturated fats. And we would have believed him if it wasn't for the two studies, the Minnesota Heart Study and the Sydney Diet Heart study being revealed and reanalyzed with all their data, or realized actually those people who had more polyunsaturated fatty fats in their diet actually had higher cancer risks. So on that line of thinking and that kind of correction, what they found is that those who are having high polyunsaturated fats, primarily from corn oil, primarily linoleic acid, I always pronounce that wrong. It's omega-6. And when they have too much of that, that becomes toxic. So that omega-6 with choline deficiency is absolutely a big causative factor for fatty liver, whether it's alcoholic or non-alcoholic. Wow. So when we look at elevated uric acid, saying, oh, it's insulin resistance, well, that's partially true. So take the insulin resistance, and let's say if you just gave them choline, you would have reduced that considerably. If you then got rid of all the garbage food, call it refined carbohydrates, absolutely. The grains and the starches out, absolutely. That would be a huge, big deal. It's like, but choline as a separate big factor is something that can be addressed almost immediately. And it's not real clever. You don't have to go out and look for some esoteric supplement. Phosphatidylcholine, start there. And most of the research, by the way, was always about phosphatidylcholine. It wasn't until the last 5 or 10 years did you get all these now different kinds of choline. Well, in the whole food world, the way that we lived at least 30 years ago, before these things were invented, and certainly our ancestors, they had lecithin that came through the food they eat, because lecithin is the wrapping, if you will. It's the membrane wrapping along with its related fats, but it's still choline that is in every cell of animals. Every cell of animals, and much less concentrated in plants. So consequently, that's where it came from, phosphatidylcholine, lecithin. I know you can get lecithin from sunflower and you can get lecithin from soy, but you also can get lecithin from the food that you eat, and that was the number one source. So it's pretty ordinary, absolutely ordinary. But it's extraordinary in the fact that we have a whole culture that has been deficient of that for, let's say, at least 70 years, since the 50s. So it's 50 plus 20, that's about 70 years. And you can go back before that. So back to men. Men have a higher need of choline, considerably higher need, 550 versus 425, except for women who are breastfeeding, right? Except for that time in their life. And that's not counting their SNPs. SNPs are a separate category of women, which is fascinating. Talked about that before. So here you go. They are the highest, and yet even at 550, it may not be high enough for some men. Men have their SNPs too, and it's not just about estrogen. Certainly that's going to be a little thing. They have other SNPs that their problems down the line is not so much in obesity and insulin resistance. That would be part of it. If they need more and they're not getting what they need, they're going to be more inclined to have the problems that come up with choline deficiencies, which are insulin resistance, which are obesity and diabetes, which are dementia, which are Alzheimer's. But for the younger men, it's about infertility. It comes right down to sperm motility. Getting those guys to swim has a lot to do with choline. So however you want to look at it, I want this to be a non-chart sort of presentation of information so you can just sort of hear this. We find that choline deficiency is so specific. It was very specific for women, especially the pre and post menopause, especially those who had the SNPs that made it so their estrogen was ineffective. They couldn't endogenously produce their own choline, and consequently they were dependent on what they ate. But for the most part, Americans didn't know where choline came from, so they didn't know where to eat it or how to eat it, if that's correct. Men are the same thing, but they had different SNPs. in a different situation. They never had the leg up, if you will, of having times in one's life of elevated estrogen. So they needed more to start with. And at least 20% as a running average, certainly from the study we've been talking about, that they were deficient. And so therefore they'd be showing the signs of choline deficiency, dysfunction of choline deficiency. Hope that's enough to keep you going. Talk more next time. Bye-bye. Hi, I just forgot to mention that, while you're listening to these different episodes, whether they're from a long time ago or something I'm doing currently each week, feel absolutely free to send me a question. Say, hey, while I was listening to you, this is what I thought. What are your takes on this? The reason I'm asking you to do that often opens up a whole avenue of thinking and thoughts, and even something I can explore for a future episode. So from a simple question to something more complicated or explain your situation, I won't get back to you necessarily right away in a couple hours, but give it a couple days, maybe even a week or so. But I pretty much get back to everybody who has a legitimate question, and I give them a legitimate answer. And sometimes if I don't know or can't give them a very specific answer, I say, I will look into it and I'll make an episode of this. So feel free to communicate. I hope you enjoy what we're going over. This is meant to be you and me on a walk together. Kind of, I'm talking to you, but you can talk back to me should you want to. Till next time, okay? Take care. Bye-bye.